It's a great pleasure for me to welcome you to this international conference on PFAS, the per- and polyfluoroalkyl alkyl substances, also known as forever chemicals.
We can find them in many, many different applications and consumer products. They are water, dirt, and grease repellent, and they comprise a group of more than 10,000 different compounds.
There are thousands of new PFAS that have been inadequately studied to understand the health effects on your cholesterol levels, for example, heart disease, a couple of rare cancers. They appear to affect the endocrine system.
So why can't they just be forbidden? Some of these compounds are already forbidden, but they are already in the environment and cannot be removed. Further discussions are going on about a total restriction of these compounds versus essential uses.
With its new scientific opinion in 2020, European Food Safety Authority EFSA set an important milestone with the establishment of a new tolerable weekly intake for 4 key human-relevant PFAS, PFOA, PFOS, PFH, S, and PFNA. As a given levels of exposure, the reassessment is a call of action.
We are part of a multinational team of agencies who are preparing a restriction proposal on PFAS. We consider striking the balance between the protection of human health and the environment and the industrial continued use of PFAS where they are necessary and cannot be substituted as the greatest challenge. Following this EU measure, we would actually need to come to a global agreement on how to deal with PFAS. PFAS do not know borders.
There are so many PFAS, and risk assessors know that we are sometimes reaching the limit of conventional risk assessment. So we invited colleagues working with new techniques to describe and understand the complex processes PFAS undergo in human more reliably and quickly.
Because they're so chemically stable, and some of these compounds are also, we call it, bioaccumulative, once they enter the environment, they can re-enter the food chain and enter our body. Which compounds can be found there and why is a question that we will try to answer.
I work in the area of creating virtual human models. My research focuses on understanding the mechanisms why PFAS persist for years in the human body. And one of the discoveries that we have made is that transporters, which basically serve as a bridge to bring molecules into human tissues, are the key determinant. PFAS actually do resemble some of the fats that we ingest, and we have transporters in the human body that actually will accumulate and take up these fats because they are needed for our health. This sort of molecular mimicry serves as one of the interesting findings that we have realized from our studies.
The long chain ones like PFOA and PFOS that are well known are of particular concern because they stay in the body for years and years. And the shorter chain compounds with fewer carbons, which have been used as substitutes, actually are excreted very quickly within days or weeks. So they are presumed to be less toxic because they stay in the body for a much shorter time. So that's good. But they're just as persistent in the environment, and if they build up to much higher levels as a consequence of being poorly regulated, then my expectation is they will be revealed eventually to be also toxic.
We lack more data on the short chain ones. The effects that we see in the animal studies and the associations in the human studies do point very strongly towards moderate to mild immune suppression. Now, whether that translates into greater propensity of infections in the general population is a little bit more unclear, simply due to the fact that this is really difficult to study. For a contaminant, external factor having this influence, this is generally not something that we like to see. On the other hand, the general public should not be very worried about their own exposure.
You know, in the 1990s, the level of PFAS was almost, depending on the substance, 10 times higher than today. So we are not talking about a risk which is increasing. We are talking now for concentrations which are lower. So this is a good message.
PFAS. They do not occur naturally, but they're industry-made. So what are the sources of PFAS that enter our body?
Even though food seems to be a big contributor to PFAS exposure, there are other sources like drinking water, indoor and outdoor air, or even cosmetics. To our current knowledge, mainly animal foods are contributing to dietary exposure. This is where we have the most information regarding the amount of PFAS in the food.
Welcome to the last session of this conference. We heard a lot about PFAS.
We have regulated mainly the food of animal origin. We know that the main part of these, of the levels in the food of animal origin relates also to the feed. The current problem is that we have not this data in feed, because feed is mainly also plant-based, mineral-based. In fact, the data which were available on fruits and vegetables, they were not sufficient sensitive to really see if there is a risk related. So there is also their work to be done on this analytical aspect, mainly also for foods and feed of non-animal origin.
I think research into the transfer of PFAS in the food chain, movement in the food chain, is becoming more and more coordinated throughout Europe, and I was impressed by the amount of new detail that we now understand and how we're moving into mechanistic models and understanding more and more of the toxicokinetics in humans and animals.
How can the data gaps for poorly studied PFAS be addressed?
We should try to request, and here we really look at the authorities, that we have a repository for the standards. We have a lot of knowledge of where PFAS is produced and used. Going close to the source, analyzing in the products will help us to identify these compounds and have an idea of which ones we see more frequently. So I think we really need prioritization.
Yeah, where are the priorities in terms of persistent contamination beyond PFAS? And that's, I think, one of the challenges we do have, because PFAS will be there for a long time, but in fact PFAS are not alone. There are others. Dioxins we have taken care of, heavy metals, and so on.
And this is where comes the challenges of methodology development, harmonization, validations. So making sure that we can translate that knowledge into something we can practically assess and use.
If we want to get rid of PFAS, we have to go to alternatives. So we have to be sure that we not go in the path of regrettable substitution. So the safe and sustainable development methods, I think they should be promoted and, well, upfront. This event is partly uplifting because we heard that the levels of legacy PFAS are dropping, but it's also depressing because there's so much still to do.
As you know, PFAS are persistent and resilient. This bearing in mind, stay persistent and resilient in implementing new research projects and advancing regulation to protect human health and the environment.